Hey, this is Mr. Benning, and we're going to look at equations today, section 1.3 in the book. We're going to look at finding solution sets of an equation if given a domain. We'll talk about domain in a minute. And it says, first success criteria is that I can understand that domain is the input and the range is the output. So whatever you put into the equation is your domain, and whatever you get out is the range. And so you can substitute a number into an equation. And you can evaluate if an equation are true using substitution and simplification. So let's look at it. So let's start off with the basic definition. An equation, if I can get my pen to right. So an equation is two expressions, either same or different, separated by an equal sign. Okay, this is also called it should be an open sentence. So an equation basically, again, we talk about expressions, meaning it does not have an equal sign. These do have an equal sign. Equations have equal signs, and they have multiple expressions. So let's talk about this one. All right, so the domain is all the values that can be inputted into the equation. So like, for example, the domain could be like all real numbers. If we're talking about speeds, it can be any speed, because you can have 54. I can go 54.7 miles an hour, or I can go 37.9, or whatever you can think of. That's a valid number. Whereas if you're dealing with a domain like people or objects, your thing is limited a little bit. So I could say I have 3 CDs. I can't have 3.5 CDs, because you either have one or you don't. If it's a half one, it's a broken one, therefore it's unusable. So sometimes the domain can be limited depending on what kind a thing you can do with that. So a domain is listed by a set, and a set uses braces to contain all the values. So it's kind of like the domain is the set, and we look at a set here. This is what a set would look like with the domain values. Okay, so it's kind of what that looks like there. So let's go back here. An open sentence is an equation that contains variables. So a variable, like look at this one, we got 2x plus 3y equals 7 minus 6y. So that would end up being, for example, the domain of x, let's look at this one, is x equals 1, 2, or 3. Is it true when x equals 1? What about when x equals 2 or x equals 3? To solve questions like these, we start to look at it. We want to know which one of those equals 9. So I'll say, okay, x equals 1. I'll do 5 times 1 minus, minus 1 equals 9. I want to see if that is true. Well, 5 times 1 is, let's erase that. 5 times 1. 5 times 1 is 5 minus 1. Well, that is 4, and 4 does not equal 9. So we know 1 is incorrect. What about 2? So I'll say, x equals 2. 5 times 2 minus 1. Does that equal 9? We can put a F there for false. 5 times 2 is 10. 10 minus 1. Does that equal 9? Well, 10 minus 1 is 9, and 9 does equal 9. I put a check and a true. And to make sure that, and we can look at x equals 3 as well. We might have more than one answer. Sometimes that happens. We can have more than one input value that works, so I always check. I'll do 5 times 3 minus 1. Does that equal 9? Well, 5 times 3 is 15 minus 1. Does that equal 9? Well, 14 does not equal 9, and that is false. So the answer is x equals 2 is the solution. And we just solved an equation for the proper x value. And to kind of go over this again, the answer to an equation is called the solution, and is said to satisfy the equation. So whenever a value satisfies an equation, or values, whatever values, if it be one or more than one, is called the solution set. And the solution set is called the range. And so when one solves an equation, they're actually just finding the answer. So we use the word solve to find an answer. Another way to write the solution, or to write the domain or range sets, is as follows. So I can use the X. I use this funny looking E that means element. And so I can say that X is an element of the set containing 1, 2, 3. So that means X can be 1, X can be 2, X can be 3. So let's look at this one. I have Y is the element. Y can be an element of 0, 1, 2, or 3. So I know that Y can be 0, Y can be 1, Y can be 2, Y can be 3. So let's look at this one. So try this one. Take those numbers 0, 1, 2, 3, plug them in for Y, and see which one of those, or which ones of those equals 3. Welcome back. Let's go ahead and quickly do these. So I'll start with Y equals 0. I have 0 times 4 minus 0. Does that equal 3? Well, 0 times anything. 0 is a big number. I'll make this easy. 0 times whatever's inside those parentheses, 4 minus 0, has to be 0. And so I can go ahead and simplify that to 0 does not equal 3, false. And so we're looking for a true. Y equals 1. I've got 1 times 4 minus 1. Does that equal 3? Well, 1, so I got the 1 here. 4 minus 1 is 3. 1 times 3 is 3. So 3 does equal 3, and that is true. But we're not done yet, because we want to make sure there's no other solutions. So we have, let's look at Y equals 2. I can sit there and say, okay, 2 times 4 minus 2, does that equal 3? Well, that's 2 times 4 minus 2 is 2. That is 4. 4 does not equal 3. That is false. Well, what about if Y equals 3? We do 3 times 4 minus 3. Does that equal 3? 3. 4 minus 3 is 1. That is 3. 3 does equal 3. That is also true. So the solution is the set containing 1 and 3. Let me make those little braces on the end. Okay, so now we want to look at this last example. I want to give you a chance to try it. But it's okay if you get confused. I want you to try it, write out the situation, and we'll talk about that in just a second. Okay, welcome back. I hope you had a chance to try it, and I hope you found what the number is. But the first thing we gotta do is we gotta write out the equation. First thing that I want to look at is I want to know where the equal sign is. So if I'm looking here, this word is, generally anytime you see that word, I want to put an equal sign there. So what's after is? Let's look at that first. That's smaller, isn't it? That's just 29. So we know something equals 29. So we got this phrase here, more than. Well, what do you think more than would be? Well, if more than, if 2 more than 4, so let's look at this. I'll pick 2 numbers. 2 more than 4. Well, that means we're adding to it. If we're putting more to it, we're adding to it. So more, you see, more than is a plus sign. So we have 5. So generally when you see a more than, it's reversed. So the 5, which is before the more, will go after and twice a number. A number, x, twice means 2. So that's 2x. So we want to look at 2x plus 5 equals 29. So we want to solve over the domain 6, 8, 12. So we want to know, okay, let's look at x equals 6. I've got 2 times 6 plus 5 equals 29. Well, 2 times 6 is 12 plus 5, and 12 plus 5 is 17. That does not equal 29, so it's false. X equals 8. 2 times 8 plus 5, does that equal 29? Well, 2 times 8 is 16, plus 5, 16 plus 5 is 21, and that does not equal 29. That is also false. Let's look at x equals 12. Now, sometimes none of the answers of the possible domain would work, and we would say the solution set would be a 0 with the line through it. That's called the null. This is called the null set. So let's look at 12. That's always a possibility. So let's look at 12. 2 times 12 plus 5, does that equal 29? 2 times 12 is 24. Plus 5 is 29. Does that equal 24 and 5 is 29? 29 does equal 29. We can check it, put it true. So I can say my solution set is just one element of 12. I hope this helps you get through the assignment. I will see you on the next time.